So this is perimeter area in like a coordinate grid. If you guys don't remember from whenever you learned it, algebra, maybe even junior high, when you are asked for perimeter, that is when you add the side lengths together. When you're asked for area, that's when you multiply the sides together. I have some pre-calc kids that still don't know the difference. Polygons are figures. They have straight sides, so there's no curvature of any of the sides. Their endpoints, like their little corners, these are called vertices or a vertex. And then when you name the polygon, you have to do consecutive order. You don't have to go alphabetical order, although that's usually what happens. But consecutive means you don't skip around, like you go one after the other. So wherever you decide to start, like if you started at C, you'd have to go C, D, E, A, D. You start at A, you have to be in order, no skipping vertices. Now, when you name your side, again, you're talking about a figure, so it's the side of a polygon is the same as a segment, so you're going to name it the same way. 2 capital letters with the endpoints being the vertices, and the little segment sign or symbol above the 2 letters. All these are vertices. If it's a single one that you're referring to, you say vertex. If it's multiple, it's vertices.
Miss Delter, I'm here.
You're here?
Yeah.
Who's on here? Oh, Ethan. Okay.
Yeah, I just joined late. Sorry.
All right. So we have 2 different types of polygons. We have convex and concave. Concave, you can think of it one of 2 ways. Like they indent. I think of them as like caves, literally. The more formal way to describe or determine which is which is if you go to one vertex, it doesn't matter which one, and then you draw lines to all the other vertices. So if I decide I'm going to go with this one, I'm going to say, okay, there's a line to that vertice. I go back here, I start that vertice, that vertice, that one, that one. Oh, that shouldn't be curved. Just imagine that it's not. This one, and this one. See how some of them appear outside like that? The second one of those connections is outside of the figure. That means it's concave. I like my way of saying it's like it like goes in, it caves in. So because that connection is outside the figure, it's considered a concave polygon. Convex, all the corners like bow out instead of in. So if I take this vertice and I connect that vertice to each of the other ones, that connection, that connection, that one, and that one, all of those connections fall either inside or on the polygon. So that's how you tell if it's a convex. Now, when you do this, this is the normal mistake that I see is students start making connections to all of them, okay? You're only picking one vertice and connecting that one vertice to all the other vertices. Don't connect all vertices to all the vertices, okay? So you got like one set of rays coming out, not rays from every vertice, so to speak. I hope you understand that. So that's the difference between concave and convex. Now, number of sides. You don't have to make a table. However, you do need to know these because not only will you be asked, like they'll give you a description and you have to put if it's heptagon, hexagon, that sort of thing, but they'll also give you the name in directions. Like you have a pentagon, the side lengths are, and then they'll ask you a question regarding that. And the side name or the polygon's name tells you how many sides it has. And for a lot of the formulas that we will use, you have to have the side numbers, the number of sides, in order to solve the problem. So if you can't associate the name that they give you in the directions with the number of sides it has, you'll be missing that piece of information to plug into the formula. So everyone knows triangle has 3, then quadrilaterals 4, pentagon, I always think of the Pentagon government building, 5 sides, hexagon 6, heptagon that has a P in it is 7, octagon, octopus 8, nonagon is 9, decagon is 10, dodecagon is 12. They skip 11, it's hendecagon. I'll write that in there. I don't know why they skip it. I guess they don't use it very often. Okay, so that's hendecagon, 12, dodecagon, and then they have names for all the other ones, but it gets kind of ridiculous. So we just say n-gon, where n is the number of sides. So if you had a 100-sided polygon, then it would be 100-gon. You'd replace that n with 100. If it's a 50-sided polygon, you'd say 50-gon. At some point, you just have to, stop and do something generic. Questions so far before we get into the examples? All right, so classify each polygon by the number of sides. You're also going to have to do by the number of sides and number of angles, but not yet. So number of sides. 1, 2, 3, 4, 5 sides. So you hopefully at some point have this memorized, but if you look at the chart, it's a pentagon. B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sides. It's dodecagon. That one right here. All right, now it says, for the second part, it says, tell whether it's concave or convex. So none of these fall inward. Like you see this, that doesn't fall inward, but as your test, I'll pick a vertice, doesn't matter which one, and connect it to the remaining vertices. So that falls on it, that connection falls inside, that connection falls inside, that connection is on. So that makes this a convex. B, pick a vertice, and you can see if I just connect these two right here, this vertice to this vertice, that falls outside, so that makes this concave. So far, so good? You guys okay? Questions? All right, I'm gonna go to the next page. Remember, the completed notes are on Google Classroom too. So if you miss something, don't panic. All right, so here's our perimeter and area formulas. Now, perimeter is linear units. It means it just has like an exponent of 1. So like inches, centimeters, miles. There's no exponent. Area has a squared exponent. So inches squared, centimeters squared, miles squared, and so on. That's area. Triangle, just add up the 3 sides for perimeter. The outside side lengths. Area is 1/2 base times height. So base in the inside height. The height and the base have to form a 90-degree angle in order to use those two together. This is a side note. A square, add the 4 side lengths together. They have 4s because a square, all the sides are the same length, so they're just trying to shortcut that. And area is still base times height or length times width, however you want to think of it, but because squares have the same side lengths, the base and the height or the length and the width will be the same. So s times s is s squared. So they simplified that formula. Rectangle, similar to a square, except for the side lengths aren't the same. So they have them labeled separately, length, width. Perimeter, they have it simplified because if you added all these together, you would have L plus W plus L plus W. So there's 2 L's and 2 W's. So that's why they did that. And length times width, base times height, however you want to think of those dimensions, multiply them together and you get the area. So we're going to find the perimeter and the area of the triangle that we're about to graph. And it's pretty center. So only falls 1 unit over. So not too tall. All right, so there's my coordinate plane. -1, 1, 4. All right, there's vertex P. There is Q, and there's R. So there is the triangle. Perimeter, remember you add the sides. So I'm going to add these side lengths together. Now this is why we learned about the distance formula and all that in the previous lesson, because you can see one of the side lengths is a diagonal. So this is 1, 2, 3 units long, 1, 2, 3, 4, 5 units long. So you have your option here, distance formula, Pythagorean theorem. Personally, I'd go with the Pythagorean theorem route because 1, it's less work, and 2, you're working on a coordinate plane, so it just makes it easier. So to find PR, you're going to use distance formula or Pythagorean theorem. All right, I'm going to use Pythagorean theorem. So 3 squared plus 5 squared, the 2 legs squared, is equal to the C. Well, C here is PR, so I'm going to put a PR. Squared. So that's 9 plus 25. That gives me 34. And I'll have to square root. Now, since we're talking about distance, chances are they're going to want us to get the decimal. And it doesn't say anything about approximate or exact. So I'm going to go with the fact that we're dealing with perimeter, and usually perimeters don't have a radical symbol in them. So we're going to say about 13.8. $34 can't be broken down anymore anyways, so if they did want radical, it would just be root 34 for that. So this guy right here is root 34, which equals 13.8. So now perimeter, we add up all three sides. 3 plus 5 plus 13.8. 0.8. Add those up. And, oh crap, I'm sorry you guys. I'm like looking at my paper to shortcut what that is. That's the answer. This guy right here is 5.8. But we want to say 5.8 here, which ends up being 13.8. Sorry about that. So that's the perimeter. It doesn't give us any units of what these are being measured in, so you can just say 13.8 units, because we don't know what the units are. Now area, if we just had to find area, it would have been a lot easier because we wouldn't have to find that diagonal, because it's just, this forms a 90-degree angle, so you multiply these together, and since it's a triangle, cut it in half. So area is 1/2 base times height. So we would have 1/2 3 times 5. So 7.5 units, and it's area, so you have to put the little squared